Okay guys, today we're going to start off by talking about factors. And factors are basically numbers that multiply together to be a given number. So let's look at number one. It says list all of the pairs of integers whose product is 36. Now remember, product means multiplication. So we just want to find all of the numbers that can multiply together to be 36. Now I understand that you could go through this a couple of different ways, but we want to make sure we keep our work nice and neat and organized because later on we're going to use it to help us find other things. So we're going to start with the most basic number that I can think of that goes into the 36, and that's just 1. And 1 we know goes into 36 times. Okay? Then what I'm going to do is just progress upwards numerically until I can't go up anymore. So the next number that I want to see can go into 36 is 2. And we know that 2 can go into 36 because it's an even number. And if you're not sure how many times, you're more than welcome to get out your calculator and take 36 divided by 2, but you'll get a result of 18. Okay? The next number that I want to see is 3. So again, if you're not sure, you can take 36 divided by 3, and we get a nice response of 12. Then 4, and hopefully you know that 4 goes into 36 9 times. The next number I want to see is 5. So if I take 36 divided by 5, notice how I get a decimal as my response, and that means that 5 does not go into 36 evenly. So 5 does not match one of those integers that I want. Next number I'm going to try is 6, and 36 divided by 6 will give us a result of 6. Now, notice down here at the bottom, I ended up with the same number. So if I progress upwards more, 7 doesn't go into 36, 8 doesn't go into 36, but 9 goes into 36 4 times, I wouldn't want to rewrite that because I already have that group right there. So once your numbers start to repeat, or you hit the same number at the bottom, that's when you're done. But an important piece of information that we need to discuss is the fact that these are not all the numbers that can multiply together to equal 36. Because if you'll remember, 1 times 36 equals 36, but negative 1 times negative 36 also equals 36. So we have our positive integers. Let's make sure we get our negative integers as well. Now we have all of the integers whose product is 36, and these numbers are what we call the factors of 36. Let's try it again on number 2. On number 2 it says list all the pairs of integers whose product is 20. So we're going to go through the same process. So first number that I know definitely goes into 20 is 1, and 1 goes into 20 20 times. 2 can go into 20 10 times. 3 cannot go into 20. 4 can go into 25 times, and the next number is 5 can go into 24 times, but again, I already have those two numbers, so that means we're done. But don't forget, you have your positive ones, now you need to come over and get your negative ones. So again, all the integers that can multiply together to be a number are called the factors. So let's go to number 3. It says list all the pairs of integers whose product is negative 15. So when we have a negative number involved, it's not much different. We're going to start by just worrying about the number. Don't worry about the sign. We'll take care of the sign in just a minute. So let's find just the factors of 15. So 1 and 15. 2 does not go in there, 3 goes in there 5 times, and that would be it. But since they have to multiply together to be a negative number, that means one of my factors has to be negative. So what I'm going to do is I'm just going to pick a side. Notice how I have two columns here. I'm going to pick a side, the left column or the right column, and I'm just going to make all of those numbers negative. So negative 1 times 15 and negative 3 times 5. Then for my second one, so on 1 and 2, how I listed all the positives and all the negatives, it's going to be similar. I'm going to list those again, 1 and 15 and 3 and 5, but instead of making my left side negative, now I'm going to make my right side negative. So over here the smaller numbers were negative, and over here the bigger numbers are negative. Let's try it again on number 4. List all of the pairs of integers whose product is 7. So 1 goes into 7 times. 2 does not go in there. 3 can't go in there. 4 can't go in there. 5 can't go in there. 6 can't go in there, but 7 can. So all I can get are 1 and 7, which means I can have -1 and -7. Well, this is interesting because the factors of 7 really just end up being 1 and itself. Numbers like that are what we call prime numbers. These are numbers which only have factors of 1 in itself. And prime numbers are infinite. We don't know how many there are. We have not found a definite amount that it ends. There's not really any pattern to them. But prime numbers only have factors of 1 in itself. Now, some examples of prime numbers would be 2, 3, 5, 7, 11. There's also 13, 17. These numbers only have factors of 1 and itself. So on 5 through 8 it says determine if the number is prime or not. If it is prime, write prime. If it's not, write no, and a number that goes into it. Now to do this, we're going to be dealing with this list of the first 5 prime numbers that we just talked about. And we're going to see if these numbers can go into these numbers. And if not, then it's a prime number. The only factors are 1 and itself. If it can, then that means it's not prime. So let's try it. On number 5, we're going to take 27, and we're going to go through my list of prime numbers here and see if any of these can go into 127. So if you need to use your calculator, you're welcome to. I'm going to start with 127 divided by 2. Now I know that doesn't work because 127 is not an even number. So let's try 127 divided by 3. If I take 127 divided by 3, notice that I get a decimal. So that doesn't go into 127. Next, I want to try 5. Now 127 does not end in a 0 or a 5, so 5 cannot go in there. What about 7? 127 divided by 7 doesn't work as well. It's also a long decimal. Finally, let's try 11. 127 divided by 11 gives me another long decimal, so none of these prime numbers can go into 127, which means this number is prime. Let's try it again on number 6, 1001. Now I know that 2 cannot go into 1001 because it's not even. But what about 3? 1001 divided by 3 gives me results, with a decimal, so that doesn't work. 5 can't go in there because, again, it doesn't end in a 0 or a 5. What about 7? 1001 divided by 7 gives me a nice number of 143. That means that 7 is a factor of 1001, so this one is not prime, so we write no, and then we write what number goes into it, 7. Let's try it again on number 7. 2079. Again, 2 definitely can't go in there because it's not even. But what about 3? 2079 divided by 3, gives me a nice number. So again, this one is not prime because 3 can go into it. Next, what I'd like you to do is pause the video and try number 8 on your own. Hopefully, you saw that none of these numbers went into 167, so that means this is prime. Alright. Now, on 9 through 16, it says a product and sum of 2 numbers is given. They want you to find the 2 numbers. Now remember, product means that we're multiplying those 2 numbers together, and sum means we're adding 2 numbers. So what's happened is they've picked 2 numbers. They've multiplied them together, and they've added them together. And they gave you what 2 numbers they got as a result. They want you to figure out what those 2 numbers are. Now to do this, it's actually not that much work. On number 9 it says find the 2 numbers that have a product of 8 and a sum of 9. So we could sit here and we could list out all of the kinds of numbers that would add together to give 9, but we would be here all day because we could say 1 and 8, or 2 and 7, or 3 and 6, or -12 and 3, or -12 and 15. Wow, goodness, -12 and 21. But since there's no end to how many numbers you could add together to get 9, let's look at the other one. What if we talk about the product? To find all the numbers that multiply together to be 8, there are a finite list, which means we just did that on the top. So what if we start by listing the factors of 8? Now remember, 1 and 8, 2 goes into 8 4 times, and then we're done because 3 cannot go into 8, and then I go back to 4. But we also have the negative ones, -1 and -8, negative 2, and negative 4. Now, out of these numbers, I want to find the two that add together to be 9. Right away, I can cross off these negative ones at the bottom because I know that they're not going to add together to be a positive number. So I just need to find the two factors that add together to be 9. So if I take 1 plus 8, I get 9. That means my answers are 1 and 8. Now I can always double check to see if I did it right. 1 times 8 is 8, and 1 plus 8 is 9. Let's try it again on number 10. The two numbers are going to have a product of 24 and the sum of 11. So that means I need to find the factors of 24 that add together to be 11. So 1 and 24, 2 goes in there 12 times, 3 goes in there 8 times, 4 goes in there 6 times, 5 can't go into 24, and then I go back to 6, which we already have, so we're done. And then we'll list the negative ones. Negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4 and negative 6. Now I need to find the two factors that add together to be a positive 11. Well, if you'll notice, since we're getting a positive number as a result, I can cross off these negative guys down here. Now let's go through the list and find out which ones add together to be 11. So 1 plus 24 gives me a result of 25. That's not it. 2 plus 12 gives me 14. That doesn't work. 3 plus 8 gives me 11. So these are my answers, 3 and 8. On number 11, two numbers that have a product of negative 14 and a sum of 5. So we need to start by finding the factors of negative 14. Now again, here's what I want you to do. I want you to start by just finding the factors of 14. So that's going to be 1 and 14, 2 and 7. Now, remember, you pick one side of your column and make it negative. Then do it again. 1 and 14, 2 and 7, and now you pick the other side. Now the sum of these numbers has to equal a positive 5. Now be careful with this because we have negative numbers in the mix. If you're adding a positive number to a negative number and you're ending up with a positive number as a result, that means the bigger of your two numbers had to be positive. So I can cross off these 4 at the bottom because the bigger numbers over here were negative. So let's see which two add together to give me a result of 5. Negative 1 and 14 add together to give me 13, and negative 2 and 7 add together to give me 5. So my two factors are negative 2 and 7. Let's try it again on number 12. Again, we want the product of negative 42. So I want you to start by just listing the factors of 42. So pause the video and list just the factors of 42. Hopefully you got 1 and 42, 2 and 21, 3 and 14, and 6 and 7. Now before I go through and I put in the negative signs, I want to look at what I'm ending up with. I'm going to be adding these together and ending up with the sum of negative 1. Now if I'm adding a positive number and a negative number and I end up with a negative number, that means my bigger number has to be negative. So I'm only going to worry about putting the negative signs in front of the bigger numbers and not worry about listing the other ones because they're not needed. Now let's go through and find out which ones add together to be negative 1. So 1 and negative 42 is negative 41. 2 and negative 21 is negative 19. 3 and negative 14 is negative 11. 6 and negative 7 is negative 1. So my factors are 6 and negative 7. On number 13, let's try it again. We want the product of 6 and a sum of negative 5. So let's start by finding the factors of 6. So again, they're 1 and 6. 2 and 3. But notice how the sum of these numbers has to be negative. Now if I had 1 and 6, I don't get a negative number, which means that I need to be dealing with the negative factors. So let's make these guys negative. If I take negative 1 and add it to negative 6, I'm going to get a result of negative 7. And negative 2 to negative 3, I'm going to get a result of negative 5. So my answers are negative 2 and negative 3. On number 14, I want two numbers whose product is 15 and whose sum is 8. I would like you to pause the video and try this whole problem on your own. So hopefully you listed the factors of 1 and 15, 3 and 5, and you found 3 and 5 add together to be 8. Let's try it again on number 15. I want the product to equal 45. So if I list the factors of 45, I have 1 and 45, 3 and 15, and 5 and 9. But this has to be negative. So that means one of these terms, one side, left or right, has to be negative. Now if my sum equals a positive 4, that means I want the bigger numbers to be positive. So this side will be negative. Now we need to find out which two add together to be positive 4. So negative 1 and 45 gives me 44. Negative 3 and 15 gives me 12. And negative 5 and 9 gives me 4. So my two numbers are negative 5 and 9. Go ahead and pause the video and do number 16 on your own. Hopefully when you listed out the factors of negative 10, you got 1 and 10, 2 and 5, and the left side needs to be negative. Now when I add negative 1 and 10 together, I get 9, and negative 2 and 5 together, I get 3. So the two factors are negative 2 and 5.